To begin notes for today, we are going to review the distributive property. So I'm going to look at problem number 1, and I'm going to see that I have a term that's outside of set of parentheses, and directly inside that set of parentheses, I have a couple terms. So what I need to do is I need to take my term that's outside, A, and multiply it by everything that's inside the parentheses. I'm drawing arrows to remind myself that I need to multiply, and then I multiply. So A times B is AB. A times C is AC. Now I look at my solution and I see, or try to see if I have any like terms that I can combine, but I do not because AB and AC are not like terms. If I look at problem number 2, I see the exact same, well, similar problem. I see a term outside a set of parentheses and a few terms inside the parentheses. So again, that reminds myself, by drawing arrows, to multiply. So negative 5 times 10x is negative 50x, and negative 5 times y is negative 5y. And again, I look to see if I have any like terms. However, I do not because x and y are not like terms. We are going to take a look at 3 different methods today for multiplying a monomial by a polynomial: the vertical method, horizontal method, and box method. The first method we'll look at is the vertical method, and if we think about what vertical means, up and down, that's how exactly we're going to put our terms. So if we remember, for example, take 10 times 2, right? If we just do a simple multiplication problem, but we show our work or write the problem down, I'm going to line up my terms vertically. That's the same thing we are going to do for multiplying polynomials, a monomial by a polynomial in this case. So if I multiply 10 by 2, if we go through this example, 2 times 0 is 0, and 2 times 1 is 2, and my solution is 20. That's exactly what we're going to do for the same type of problem. So I'm going to list my polynomial, my larger polynomial, first, so negative 4a squared plus 2a minus 7, and then that times 5a squared. And if you notice, I'm lining up all of my terms vertically. I zoomed in a little bit so the problem is easier to see. And now let's go ahead and multiply. So I'm going to take my 5a squared and multiply it by 7. So 5a squared, times negative 7 is negative 35a squared. So again, that was 5a squared times negative 7. Now I'm going to look at 5a squared times 2a, and I get 10a cubed, and 5a squared times my last term, negative 4a squared, and I get negative 20a to the 4th. And again, this was a positive 10a cubed. And now I look at my final solution, and I say, can I combine any a to the 4ths with a cubes with a squared? I cannot. So negative 20a to the 4th plus 10a cubed minus 35a squared is my solution. And for the next method we are going to look at is the horizontal method. And horizontal again means side by side or flat. So what that means here is I'm going to take my first term, negative 6x cubed, and multiply it by everything inside my set of parentheses and list out those terms side by side. Therefore, being the horizontal method. So I'll color code this too so it's easier for you to see. So I'll take my first term, negative 6x cubed, multiply it by 3x to the 4th. So I have negative 6x cubed times 3x to the 4th. And I'll change colors and take my term negative 6x cubed again times the second term I see. And I'll add these together. So negative 6x cubed times negative 2x cubed. Change colors again, and I see negative 6x cubed times negative x, so I'll add to that negative 6x cubed times negative x. And last but not least, change colors again, take negative 6x cubed times 9. And now that I've listed out side by side all of my terms that need to be multiplied, I'm going to go ahead and multiply them together. So negative 6x cubed times 3x to the 4th in purple gives me negative 18x to the 7th. I'm going to add to that negative 6x cubed times negative 2x cubed, and that will give me 12x to the 6th. And then down in blue, negative 6x cubed times a negative x will give me 6x to the 4th, again positive, because negative times a negative is a positive. And last in green, 6x cubed, oh, doesn't look like the negatives there. Add that negative there so I can see that, times 9, and that should be negative 54x cubed. So my final answer here is 18x to the 7th plus 12x to the 6th, addition sign there, plus 6x to the 4th minus 54x cubed. And I look for, again, to see if I can combine like terms, and I cannot, so that problem is complete. And the last method we'll look at today is the box method. And again, you can choose whatever method is easiest for you or that you prefer to use. And the box method, I am going to draw a box and place my terms outside the box, and then the product of those terms will go inside the box, and that's how I will see my solution. So to get this started, let's look at what we're multiplying together. I am multiplying a monomial, or one term, by a polynomial, and here it's a trinomial because I have 3 terms, so it's a 1, it's going to be a box of dimensions 1 by 3. And again, the 3 came from the 4y squared minus 9y minus 7. That is a trinomial because it has 3 terms. So I'm going to draw my box, and I can draw this vertically or horizontally, and I'll show both methods. So it's going to be a dimension of 1 by 3. And then on this one side here, I'm going to list 6y, my monomial, because that's the dimension of 1. And then above, my trinomial, which was 4y squared minus 9y minus 7. And now I'm going to take the product of 6y squared and 4y squared and put that inside the box, which would be 24y to the 3rd. Then in the second box here, I'm going to put the product of 6y and negative 9y to give me negative 54y to the 2nd. And then last, in my last box, will be 6y times negative 7 to give me negative 42y. Now I look at my solution in my box, and I'm going to rewrite it down to show my answer, but I can already tell that there are no like terms. And how I know that is because the 2 terms I multiplied by starting with had different degrees. If you notice, 6y has a degree of 1, and 4y squared minus 9y minus 7 has a degree of 2. And then it's in standard form, so in decreasing order. So I can tell I have no terms, y cubed, y squared, and y. None of those are like terms, so I'm unable to put those together. Or I could also make my 1 by 3 box vertical over here, right, dimensions 1 by 3, and I'll put 6y, the monomial, one term, where the one-sided box is, my 4y squared, negative 9y, negative 7, and then I go ahead and multiply as I did before with my horizontal box, and I should, and I will, get the same answer. The other part of 7-6, multiplying a polynomial by a monomial, is doing that and solving an equation with variables then on both sides of the equation. So you're using the distributive property and you're applying that to solve an equation. So this really shouldn't be too difficult because you've already done equations for quite a while now. But just to remind you, so you don't forget, draw my train tracks, and I want to isolate y and get y on one side of the equation and the other numbers on the other side. So I would first look at and combine 5y minus 2y and get 3y equals 3y plus 2. Let's isolate y. So I'll first try to get all the y's on one side. So I'll subtract 3y. And what I'm left with now on my left-hand side is 0y, which I'm not even going to write because that's 0. So I have 0 equals 2. And we think about that, and can 0 ever equal 2? It cannot equal 2. So this is actually a special case problem where if your number on your left-hand side is not equal to the number on the right-hand side and you have no more variables left, this would be no solution, or as I like to write, 0 with a line through it. no solution. Okay, and if we look at our next problem, I realize in here, my notes, I have a typo. On your notes, this should say 3u right here, I believe. So I'll go ahead and make that change in here. And now I see that I need to use the distributive property because I have a term directly outside a set of parentheses on both sides of my equation. So I'm going to go ahead and draw on my train tracks and just use the distributive property. So I'm drawing in my arrows to remind myself that I need to multiply. And 3 times 3u, again I had to add that 3 in, was 9u plus 6 plus 5 equals 4u minus 4. And now I'm going to combine any like terms if I see those. So I see that I have 6 plus 5 on the left-hand side, so I have really 9u plus 11 equals 4u minus 4. And I'm going to put all the u's on one side, the numbers on the other, so I'm going to make a couple moves here in one. I'm going to subtract 4u from both sides, at the same time subtracting 11. What I end up getting is 5u equals negative 15. Last step to undo multiplication problem is to divide. So divide by 5, so u equals negative 3. And a way I can check my answer is by plugging in negative 3 back into my original equation up here, wherever I see u, and that will work out. I'm going to save time and not do that, but you should be checking that. For our last notes, we are going to look at a word problem. So let's take a look. The theme for a school dance is solid gold. For one decoration, Kana is covering a trapezoid-shaped piece of poster board with metallic gold paper to look like a bar of gold. If the height of the poster board is 18 inches, I'm going to highlight that right now, how much metallic paper will Kana need in square inches? So first, we would need to figure out to write a polynomial to represent the area. But do we know area for a trapezoid? We sure do, right there. Area equals 1/2 times the height times base 1 plus base 2. So let's fill in everything we know into this formula right here, given from our given information for this problem. So A equals 1/2 times the height, and we know that, but I'm going to wait to fill that in for a little bit because the problem will be simpler if we do it this way. 1/2 h times our first base, and our first base is h plus 1, and we're going to add to that our second base of 2h plus 4. Now I'm going to simplify inside my parentheses because I have some like terms to make this problem easier, so I'm going to do that. So here I go. I'm going to take h here and add 2h with that and get 3h. Going to add the 1 right here plus 4 and get 5. And now I still have area equal to 1/2 height times my bases. And I've already combined those like terms. And now I'm going to use that distributive property because I see a term in front of a set of parentheses with terms inside that. And again, this is a monomial times a polynomial here. So I could use whatever method I would like, vertical, horizontal, or box method. I'm going to use the horizontal method, the distributive property, and multiply those across. And 1/2 h times 3h, if I write this over here, 1/2 times 3 over 1 is 3 over 2. And they now combine the h's. So area equals 3/2 h squared, because h and h give me h squared. Now I take 1/2 h times 5, so 1/2 times 5 over 1 equals 5/2. And I add on the h, so plus 5/2 h. Now we're not quite finished with this problem yet because the question that was asked was how much metallic paper will Kana need in square inches? Well, we have one step left to do. We know the height of the poster board in that red highlighter there is 18 inches. So if I go back down to my problem here, I want to plug in 18 for what variable? You guessed it, I want to put that in for h here, 18 there, and 18 there. Now this is a computation problem that I'm going to use my calculator, and if I plug that in exactly as I see it, 3/2 times 18 squared plus 5/2 times 18, I will get 531. And how do I label this? Inches squared. And now I'm completed with this problem.